software. He was there for 6 years and then pretty much started getting involved with the Khan Academy and knew this was the place for him. And so without further ado, here's Ben.
Yeah, hey guys. Thank you. Thank you. I'm gonna make it darker in here. If you guys start falling asleep, punch somebody next to you. I don't know, but at least this way you can see the different colors. And yeah, I guess tell on your neighbor if you start falling asleep. So I want to tell a whole bunch of stories about what it's like to develop software at Khan Academy. These are our 5th graders. They're actually really well behaved. I chose those monsters because I like cartoons and I thought those were kind of cute. And I want to start off by letting some of those 5th graders tell you about what it was like when they were learning math before they used Khan Academy. And this will probably sound pretty familiar to some of you guys.
Our teacher would have the textbook up on like the overhead projector so we could all see it. Kind of just sat there. We did like different sections.
Well, I'm a daydreamer, so I kind of zone out sometimes.
We'd read the lesson and then we would get homework.
Always a test at the end of each section.
Yeah, that's how it was before.
So that probably sounds familiar, and the rest of this talk is going to be about the type of problems that we have to solve when we start rethinking how education works, and when we start getting into schools, what kind of situations did we run into? So all these stories are going to be true. This isn't, the guy's not actually named Bob, that's not actually a 5th grader, but I will tell you a true story about fictional Bob. And it's not just 5th graders, we've got 7th graders, we've got people all over the world using Khan Academy, millions of users per month. But a lot of the stories today are going to be about the pilot classrooms that we work with very closely to learn more about usage of Khan Academy. Just so I can get context before I go on any further, how many of you guys have heard about Khan Academy? Okay, good. How many of you guys have used Khan Academy? Sweet. How about, how many of you guys have seen Sal Khan's TED Talk? Okay, a pretty good number. So for those of you who have seen his TED Talk, this next 20-second clip will be a little bit of a reminder, but for those of you who haven't, this is Sal talking about the types of videos that he makes. And just to remind you, Khan Academy started because Sal started making a whole bunch of videos to teach anybody anything. And here's a quick montage.
So before I go any farther, let me show you a little bit of a montage.
So the hypotenuse is now going to be 5. This animal's fossils are only found in this area of South America, a nice clean band here, and this part of Africa. We could integrate over the surface, and the notation usually is a capital sigma, National Assembly. They create the Committee of Public Safety, which sounds like a very nice committee. Notice this is an aldehyde, and it's an alcohol. Start differentiating into effector and memory cells. A galaxy. Hey, there's another galaxy. Oh, look, there's another galaxy. And for dollars is their $30 million plus the $20 million from the American manufacturer. If this does not blow your mind, then you have no emotion.
So that's Sal, and here we go on a whirlwind history just to get you up to today. This is Sal on his own. This is what the webpage used to look like. He's just recording video after video, anything he can think of. He's really found his niche. I've seen Sal with a bigger smile on his face than, it causes a bigger smile than anything else just because he opens the door and a guy from Amazon delivers a box of textbooks and he opens it up and he's like, quantum mechanics, yes, I get to learn and then spit this back into YouTube. He absolutely loves it. So this is what he starts doing. His YouTube readership is growing 1 million, 2 million, 3 million, these days over 82 million views. But what a lot of people don't know is that he started the Khan Academy with some software. He's got a software engineering background, and he built these interactive exercises that let his family at first and then anybody else test their knowledge in all types of different, for now, math subjects. Traffic keeps going up and up and up. This is our real Google Analytics data. And again, when it's still Sal, he starts getting all this feedback from all types of different users, really powerful stuff. Here's somebody on Facebook. I just wanted to say thank you. My daughter has struggled with math some time now, and I can tell you after one day she is a changed girl. Seriously, she woke up and was at the table writing out her own math problems this morning. I'm so excited to see her self-confidence back and even more excited to see her skills grow. I'm going to tell all of the parents about it. And then there's an immediate response. Curtis, my daughter has been struggling for years with math. She's 11 and it was a nightmare. No matter what they did in school, she just could not get it. Last night I went to the site and she fell in love with it. She was on it for a few hours and only got off when her friend came over. A complete turnaround, thank you, is not enough. He's getting more and more of this. People are submitting video blogs. Here's a teacher blogging about how they're implementing Khan Academy in the classroom. he's hearing about this more and more. Here's Facebook posts from yesterday. Or actually this was today, I think. I was looking at it. Kids saying that they were about to drop out of school if it wasn't for Khan Academy, or you saved my dreams of becoming a doctor. So he realizes something. He's getting all this feedback and he realizes something.
And then other things started to dawn on me. That not only would it help my cousins right now, or these people who were sending letters, but it could maybe, that this content will never go old, that it could help their kids or their grandkids. If Isaac Newton had done YouTube videos on calculus, I wouldn't have to. Assuming he was good. We don't know.
So he decides to turn it into a real organization. Oh, by the way, you can tell he's a really good public speaker. So I asked him coming here, I was like, Sal, do you have any advice for, speaking to all these students? And he said, I was expecting a laundry list of tips or a couple profound things, and the only thing he told me was, smile so much that they're convinced you're drunk. So I don't know if you think I'm drunk. I'm not. If I am, I guess I'm doing my job. I'm not really sure. But anyway, so he gets funded by the Bill and Melinda Gates Foundation, and he wins Google's Project 10 to the 100, and we start building out the team. We're growing slowly at first. Now we're growing a lot more quickly. Al Gore is not actually on our team. He came to visit, and Sal argued with him a lot about global warming. And while that's going on, we're starting to implement officially inside of classrooms. So this is a 5th grade classroom who has completely, or at least significantly, replaced their math curriculum with the Khan Academy. These students come in every day, and they sit and work at their own pace and work on whatever exercises they need to work on. And the teachers just go around and help them where they need to be helped. There's one of those little monsters in every picture, so if you're really bored, you can just try to find the monsters. And we start getting implemented in more and more classrooms. We went through a really good pilot program last year, and now this year we're branching out into hundreds of different pilot classrooms. And here's some more pictures of that. Meanwhile, while that's going on, our team's growing, and we're starting to rapidly increase the amount of content, not just in videos, but in interactive exercises that are on the site. What you're looking at right here is our knowledge map. This is it's built on the Google Maps API. That's all open source. You can play with it if you want. But you can click and drag this around and zoom in and out and jump into any point basically at right now K through 10, K through 9 math. We don't have calculus covered. We're working on it, and we're filling in gaps here and there. But while this is going on, just keep in your mind so you know the history of Khan Academy, we're filling this in quickly. And we're filling it in with cooler and cooler exercises. Here's an example of the derivative intuition exercise where you have to match up the derivative of this curve at various points and try to get a little bit of an intuitive understanding of what a derivative is. And we start helping out the teachers. Right now, so this is a graph. Every row here is a student. Every column is a math concept that students are working on. Can anybody spot which student and which concept needs some help? It's probably pretty obvious, right? There's a big red thing right there. And that's what the teachers have. If I handed you a stack of tests or a whole bunch of a whole bunch of workbooks or whatever, how long would it take you to find that student? Probably an extremely long time. So this is technically not that hard. It's a chart. But for a teacher, this is a world of difference. So we started giving more and more of that out. And here's a teacher.
Well, it's so right there and immediate. It's a quick picture of where students are at, where they are having issues, where their struggles are.
So I know who I need to visit with and where I can help them, where I can come alongside and remediate and support.
They love those aha moments where they can be the teacher and they can tell me about something that they think I don't know how to do.
So that just brings us to today, and we've been flying really quickly because I want to get to today, and I want to give you guys some context for the stories that I'm going to tell you. These days we've got over 82 million video views. When I first made this slide, we were at 171 million practice problems done. Now we're at over 180 million, with almost 2 million practice problems done per school day on the site. That's just the math practice stuff. But what this talk's really about is not those numbers. It's about the stories that we run into when we start trying to change education, when we start trying to let kids drive their own education. What kind of problems do we run into, both from a usability standpoint and, therefore from a technical standpoint? So here's what development is like at the Khan Academy. We're super shipping friendly. We ship 3, 4, 10 times a day. If we ever have a block of code that's sitting there for 2 weeks undeployed, we get nervous. We don't really like it. Unless it's been, maybe it's a big feature that we've designed and iterated outside of the code a whole bunch, then we'll wait that long. But we really are dedicated to moving quickly because we believe that we're at version 0001, and everybody else is right there with us. And educational software, where it will be in 5 or 10 years, is nothing like what Khan Academy looks like right now. The only way to really embrace that belief is to embrace shipping quickly, iterating quickly, and then shipping quickly again. So, that's what we're all about. When we ship, then we'll go into the classrooms and we'll figure out what's going on and we'll look at our data. We typically go down one of 3 doors here. Let's open door number 1. Door number 1 is when we open a door and the 5th graders just start screaming at us that things suck. It's actually really, really powerful. Has anybody here, have you guys tried to run usability tests before? Who here has? Okay, yeah, a bunch of people have tried to run them. It's tricky. You have to get somebody who's honest. Your friends know that you've been working for a long time. If you pay people off Craigslist, they don't really understand much of what's going on. Our 5th graders are phenomenal. They don't even take the time to tell you how to fix it, which is the really annoying part of usability tests. They just tell you that things suck. This is real feedback from last week. We changed something called the streak bar, which I'll talk about in a minute. The streak bar looks stupid. It's also kind of funny looking. So they wanted to make sure that we didn't just fix the stupid part. We had a funny looking part as well. And we get that stuff all the time. But the feedback story that really sticks into my head is actually not from a 7th grader. It's from somebody who's much older. And it's this. And what this is one night it was during the summer, and I'm laying in bed and I was reading blogs about the Khan Academy, specifically this one teacher's blog in Oakland who has started implementing Khan Academy in their summer school. And so these are kids who are coming in, working during the summer to either catch up or get ahead. And then the teacher's videotaping them and getting responses and making an experiment out of it. A phenomenal teacher in Oakland. And so I click on this kid's video and I want to hear what he has to say about Khan Academy, and this is what he says. It's kind of slow. Just before I came by here, it froze. I don't know if it froze, but it said my streak was ruined, and then it took a whole long time to get back to work. I remember that really well because I instantly started sweating. I felt terrible. This wasn't like the kid had trouble harvesting his pig truffles on Farmville or whatever. He doesn't even care about the software. He just wants to learn. And our crap code or my crap code was stopping him from learning. So, this piece of feedback was really harsh for me. We were getting a lot of it over the summer, actually. I immediately commented and I wanted to help him out. But we were seeing more and more of it over the summer, even though it was the summer. We'd expect, speaking of traffic patterns from the last talk, we would expect our traffic to drop, but our traffic was maintaining level during the summer, which meant we knew we were headed for an explosion, and we had to fix complaints where people thought our site was slow or it was broken, especially if they were happening over the summer. The other thing is that once you get bad feedback like this, it ruins everything else. I'm sure you guys have been through this, so here's some good feedback.
I used to get B's all the time, but since Khan Academy, it's brought me up to an A, so that was really cool. And the way I use Khan Academy is I do the exercises and it really helps me improve my math skills, and I watch the video.
No offense, but who cares? Because I feel so bad about the other guy that I can't appreciate all the good stuff. Here's more of that Oakland classroom saying it was a great experience, it was a success. The teacher's asking them for feedback. The Khan Academy is great, it's fun. I didn't know how to interpret this one. I don't know if he's sleepy. Maybe our software is sleepy, I don't know. But the bottom line is that I can't enjoy the good stuff anymore. None of us can, because there are people out there who are struggling. So we had to make the slow stuff stop. And in order to fix the slow stuff, you have to really embrace performance as a culture. You can't just go fix whatever small problem or you can't just wait for it to get bad and then fix that problem. You have to have a culture where your development team is not prematurely optimizing, but really believes that performance is critical to user happiness. We did that with in 2 different techniques. And the first technique, again, I'm really happy with the timing of the talks here. The first important thing to mention is that our entire stack is on Google App Engine, which means that we offload a ton of our responsibility of scaling and worrying about speed to the cloud, and it's been phenomenal. It means that when things like this happen, when Sal goes on Colbert, it doesn't matter for us because Google servers can handle Colbert's traffic. So that was a major decision for us. We have a development team of 8 people, 2 designers. So 6 full-time developers. None of us are capable sysadmins. None of us have hooked up a machine that is a public traffic serving machine. It's all on App Engine. We just submit our app and we go. It's been really great for us. But we had to make a big change this summer, and that change was connected to something in App Engine called the High Replication Datastore. Has anybody here used App Engine? Okay, just a couple. Well, even those who haven't used App Engine, you guys know that normally you're hooked up to one data store. Maybe it's MySQL, whatever you want to call it. But we'll be talking about App Engine's big table here. And if you need to put data into that data store or get data out, if you've got one connection to one data store, you're in a pretty dangerous spot. This is what Mark talked about. If things start getting slow, maybe there's like a locality problem on that data store with where your data is. You're hosed. Things are going to start getting slow for you no matter what. You've only got one connection. You're out of luck. So we switched to, and we took advantage of a whole bunch of work that the App Engine team did recently when they released the high replication data store. And what that is there are multiple data stores that you can connect to here. Anytime I call a GET or I put something in the data store, I could be talking to any of these data stores. I don't know which one I'm talking to. So that presents an issue from our standpoint, because maybe I try to put that GNOME in a data store and then I try to get it back out a second later and I read from that data store. That could happen all the time. Google's working hard to make sure these are synchronized, but there are lots of race conditions to worry about. So we had to go through our code, find all the spots where that could happen. That's called an eventual consistency problem. And we had to make sure, either through tricks of the UI or actually, working through the code, we had to make sure that we could handle this new system that talked to multiple data stores at once. And as soon as we did that and we made the switch, a whole bunch of our problems went away. So that was, major step number 1 in fixing Khan Academy performance this summer. Major step number 2 was building this thing called the App Engine Mini Profiler. What that is anytime a developer on Khan Academy looks at any page, here's a shot of the home page, they'll see this. You've got this little thing in the upper left-hand corner that shows you how many milliseconds it took to render that page on the server. And it's not just that little thing. If you click on it, it'll drill down and give you a full profiling breakdown. So you can see every single function call that was involved in creating that page. You guys are probably used to this. You've seen profilers before. But the critical thing here is that this is always on for all developers of the Khan Academy anytime they are using Khan Academy. And it doesn't affect the performance of the live site for anybody who's not a developer. Typically, when you have a profiling tool, you have to instrument into your code and hook up all these events and hooks and stuff like that are going to slow down the speed at which the code runs. So a lot of times, if you have to profile the live site, you do these things where you only profile 5% of people and then you turn it off because you don't want to slow everybody else down. Blah blah blah. This is hooked up in a way such that only the developers are paying the performance penalty to get this data. Nobody else does. But now when a developer is browsing around the site, you see when things are slow and you can't help but click on it. So, big lesson number 2 is if you're worried about performance of your web app, go to some work to just put your profiling data in front of all your developers. That's it. And then just let the magic happen. Because you have to click on that thing when it's too big and you at least start learning about what's slow. Here, I'm actually expanding a little bit of a different profile here. This is not just a profiling breakdown. This is showing me all the times I'm talking to the data store, anytime I talk to Memcache, any type of RPC call, I'll get the full profiling information from that with the mini profiler. And it does some other really cool stuff. See how there's two millisecond counts stacked up on each other there? Anytime you make an AJAX request on the site, it will also profile that AJAX request and stack it up. So if you load a page that does 5 AJAX requests, or you're interacting with the site in an AJAX-y manner, you'll also see those profiling stacks queue up there, and you can click on them and see all the profiling information for an AJAX load. Here's an example of the initial page load took 115 milliseconds. Great, everything's good. Then we had this AJAX load that loaded all this data over here, and that took over a second. Bad. Let's click on it and dive in and figure out what's going on. It goes one step further as well. A really common pattern, I'm sure you guys know in web app development, is that when you want to update data, you issue a post request, you update the data, and then you redirect the user back to a GET request, and then you display that data. Very common pattern. A lot of times if you have a profiling tool hooked up to look at the performance of your requests, you'll only be looking at the performance of the GET request that came back. This tool will actually track the chain of redirects. So what you're looking at here at the top is the result of the post that then redirected back to this page here. So this combined with the AJAX change, combined with putting this on the live site, means that a developer doesn't miss various losses in performance that they would otherwise miss if we didn't have this tool available. And we released this open source. So if you're on App Engine, you can drop this in like 2 seconds. It's on GitHub. Our account's con/GAE Mini Profiler. Go drop it in. But I also want to point out that we totally copied Stack Overflow here. This was all Stack Overflow's idea. I was fortunate enough to have a lunch with a bunch of those guys and have it be fully drilled into my head that they're much smarter than me. So they released for ASP.NET MVC a very similar tool. We optimized it for App Engine, but if you're on ASP.NET of any type, or I think maybe specifically for MVC, go use their tool. And if you're not on either and you're building a web app, you have the opportunity, following this pattern that I've just described, I think, to make a really cool open source project. Especially while you're in school with an independent study or with a couple free days, you could go make a mini profiler that has these specific qualities that I'm talking about for whatever framework you're using if it doesn't already exist, and you would get a lot of traction. I released the mini profiler and we immediately have it used on a whole bunch of sites. So for those of you looking for a cool open source project to work on, I really suggest going and building one of these for whatever web stack you're on. So we made those two major changes. We get fewer and fewer complaints. People aren't really yelling at us anymore about things being slow, so finally I can enjoy the good stuff that's going on Twitter and not want to shoot myself. And we're back to our main three doors here. Let's go down door number 2. Door number 2 is when we walk into a classroom and a kid starts screaming, "This is sweet! This is awesome!" And it's actually a wolf in sheep's clothing because they're doing math. So we make math pretty cool. It's really cool. We make math like maybe 3 E's past the awesome, but if they're screaming 7 E's, then we might have screwed up somewhere. Because, well, here's a specific story to share. One time I went into a classroom and a kid's waving his hand around, and he's like, "Ben," he would get so excited when I came in. He's like, "Ben, come check this out. I have a streak of," and that's wrong, I think it was 950. "I have a streak of 950 correct problems in addition 1. He's so proud. And addition 1 is literally 9 plus 1, 2 plus 3, 6 plus 2. He's in 5th grade. None of the answers total to over 10. I think that's the definition of addition 1. But he's so happy, and he's showing me his profile, and he's been working nights. He's been working previous nights. One kid actually, not this kid, but one kid, woke up at 3 a.m. to start working on things so that he could come into the classroom and have all these awesome badges. So this kid's looking at me with these big eyes, and he's so happy. And I had to be nice to him, but secretly I'm thinking, great. I'm going to shoot myself in the head again. This is terrible. This kid isn't learning anything new. So what's going on? What did we screw up here? Here's the user interface that's to blame. If you work through Khan Academy right now, you get problems correct and you build up a streak. This is actually different than what it is right now, but you'll build up a streak. And so if you get 2 problems right, you get a streak of 10. If you get 1 wrong, it goes back to 0. You'll get a streak of 2. Once you get a streak of 10, then you're deemed proficient, and we say, you're ready to move on. You could keep going, though, and there are a couple awards you can get for getting a streak of 20 and 40 and 60. There's certainly no award out there for 897. But the thing is that this number would keep increasing, and that was it. You didn't get any points. Like, the points had fully degraded, but just the fact that that number kept increasing every time the student kept doing the problem was enough to drive the student to continue working on something that they didn't need to be working on anymore. And that's kind of an important lesson, because when people think of game mechanics, they think of badges, leaderboards, points, all types of really complicated stuff. But a game mechanic, a powerful user interface mechanic is anything that is responding to the user in any way that makes them believe the system wanted them to do something. That number going up meant that they could brag to their friends. They could say, "I have a streak of 900 and you only have 500. So what do? Enormous change. The streak that we display is the streak if the streak is less than 100. Otherwise, we show the text max. That's it. We still track the data. You could do 897 problems, but that's all we show the users. So now, we literally went outside the classroom, brought out our laptops, coded up, and shipped it while they were there, which was kind of cool. Sometimes they don't like us because we take things away. It's okay. We actually have one person who we say has to be the bad cop and tell them about the good or the bad things we do. But so this is the change. If you've done 99 problems correct, you see 99. If you've done over that, you just see max. That was it. Immediately solved all of our problems. The deeper question here, this is just one story. The deeper question here is how do we learn from this? How do we not make these mistakes in the future? How do we use this to drive what we consider to be good learning behavior on the Khan Academy? So what we're starting to do is more and more data-driven experiments. What you see here, I'm not going to show you what we were A/B testing just yet, but you're seeing the result of an A/B test. Just in case anybody doesn't know what an A/B test is, A/B test is just saying that if I take 50% of my users and give them one experience on the site and 50% of the users and give them the other experience, we can keep track of which one behaves in a better way. Typically, it's used to figure out how to make more money. For us, it's a little bit different. We can keep track of making a change. How many users made it through 10 new mathematical concepts on our site? How many users made it through 30 problems? Made it through 1 mathematical concept? Made it through 20 problems? We learn all types of stuff like that, and as time goes on, we're becoming much more data-centric. The A/B test results that you just looked at are this, is the difference between these two exercises. You can't quite see it, but there's a blue line here. Hopefully you can see it. Up at the top is the old version of the exercise, down at the bottom is the new version. And the difference is this tiny thing. We call that Mario points. You guys know how when you play Mario and you grab a coin, it goes like ding, and then the coin spins up and disappears? Yeah, so we wanted to do something similar for our stuff, so now if you're working through problems, this little thing called Mario points will just quickly show up, show you how many points you got, and then fade up and out and go away. That was the only change. Pretty small. It also had a small but statistically significant effect on the number of people who made it through 10 mathematical concepts. Pretty interesting. That type of stuff is pretty engaging when we start thinking about it. But it's really just the beginning. We have a lot of content. We have a lot of users, and we have a lot of different ways to work through our content. So this ability to A/B test is important to us, which is why we built this framework. But we're just starting to get our feet wet. In order to do this stuff, we built another App Engine specific framework. If you're on App Engine, go drop in. It's called GAE Bingo. It's based on A Bingo. How many of you guys hang out on Hacker News? Anybody read Hacker News? Okay. Yeah, so you guys might know Patio 11, Patrick McKenzie. He wrote this A/B testing framework called A Bingo. We somewhat cloned it with a couple changes specific for us, and it has a few key properties. One is that if we need to run an A/B test, if we're curious about the effect that a change might have on how many how many topics a student works through, we can run that in one line of code. So what you see right here is we're saying, if A/B test Mario points, then show Mario points. And A/B test, you don't have to set anything up. You don't have to use an admin interface. You just write that line of code. It will return true 50% of the time and false 50% of the time. Keep it consistent per users and all that magic stuff. So 50% of the users will see show Mario points. It's also highly optimized. We're on App Engine these days during our peaks. We have about 500 requests a second, so we can't have our A/B testing framework slowing us down, which combined with number 3 is difficult. Number 3 is we have to have our data persist long term. We have to know if we say we have a new way of teaching fractions, which I'll show you this later actually. We have some new exercise that teaches fractions in a different way. If we send 50% of our students through one way of teaching fractions and 50% of our students through another way, what happens at the end of the year when they take their offline end of the year assessment? We want to be able to compare those things. So it's not like we're just trying to store our A/B test result history long enough to figure out if they click checkout with PayPal. We actually want to know for long term, is real learning happening as a result of these changes that we're making? And that's a very difficult problem to answer, but it's one that we believe an answer that we believe is hidden in our data somewhere. Just a couple other quick examples of how we can run A/B tests and how dedicated we are to making it easy so that anybody in the company can jump in and run an A/B test. You saw the first example already. In the second example, let's say we're trying to test a new company name. We can pass in specific alternatives to the A/B test. In this case, we're either naming the company Khan Academy or Khan. And the third example, maybe we're testing how many points to award for a specific action, and we can give a whole bunch of alternatives. It doesn't have to be just A or B. In this example, for those of you who are familiar with Python, our whole stack is Python, by the way, about half Python and half JavaScript. Anything that can be pickled in Python can be returned as the result of an A/B test. So here we have Monkey Bob and Monkey Bobette. Both of those can be handed back. If you run this call, 50% of the time you'll get Monkey Bob, 50% of the time you'll get Monkey Bobette. And you can also weight your alternatives. If you're really scared of one of your changes, you can say, I only want that thing 1% of the time and this one 99% of the time. Then for those of you who have run A/B tests, on the other side of things, you have to be able to mark a conversion. You have to be able to say, when did something good happen as a result of this experiment? And staying true to our A Bingo roots, it's one line of code. If somebody becomes proficient, you call Bingo proficiency. If somebody gets a badge, you call Bingo that. And then you'll be able to see on our dashboard what's statistically significant. Which changes that we're making have the largest impact. And that's been a big thing for us. Like I said, this is all available. This is drop into App Engine right now if you want A/B testing. If not, if you're on Rails, go use A Bingo. If you're on a different framework, again, I encourage you to clone one of these, although I think this one has been cloned into a number of frameworks. If you're on .NET, I think there's a clone, but it's a good A/B testing tool. So just keep in your mind, thinking about all those different A/B test possibilities, keep in your mind what we're talking about. We're not just talking about Mario points. We're talking about the ability to route somebody down entirely different methods of learning large academic concepts and figuring out the effects of those routes. Back to our students. Let's go down door number 3. Door number 3 is actually the good door. This is when we walk into a classroom and people are just working together. They don't look at us. They're not even working with the teacher most of the time. They're in groups. They're saying, solve for R. Check out this badge I got. How did you do that last night? And what's actually happening in the classroom is this. Groups of students have paired off and they're working on all types of different topics. Some people are working on geometry, some fractions, some word problems. There's no choice but to work together because there's only one teacher. So this is a pretty big departure from the typical teaching environment. The teacher can only deal with one person at a time. You have the only thing you have in front of you are your friends and the resources that we're giving you in Khan Academy. So people start working together on all types of different topics, and it's awesome to go on and see this. It's really encouraging. Kids get excited, and they're working together. And what's actually also going on is that there's probably a 5th grader working on trig. We see this over and over again in our classrooms. Specifically, these kids would have been learning fractions. So it's really encouraging to see this type of stuff, and we see it over and over again. And as proof of it, here's some real data from one of our Los Altos classroom pilots. This is a graph. I didn't run a report or something. This is a real teacher's user interface. This is a graph of how long you've been working on the site over time and how many modules you've completed. Those are the lines you see. The highlighted dots are because I put one filter on this to say only show me the dots where somebody learned a trig module. It's a specific trig module. So the acquisition of this knowledge cannot be explained by the teacher handing it out because the teacher doesn't teach trig in 5th grade. You see these groups, and we see it over and over again. And what's happening is that the groups of students, one kid learns it, and then he'll tell his friends, or maybe he doesn't want to tell his friends, but he shows off his badge to brag, and then everybody else starts trying to learn that thing. So you'll see these, like this dissemination of knowledge in these little groups, even though the teacher isn't playing any part in it. And that's one of the really exciting results that we're seeing from Khan Academy. But my favorite story by far is one that happened, I think, 2 weeks ago, or even less, when our school implementations team went into a new classroom, and they're watching the kids use our software. The teacher's over in the corner somewhere, and there's a girl using the software, and the school implementation team is watching her use the software. The girl notices the Khan Academy team seeing her use the software. Teacher's far away, and the girl starts freaking out. Please don't tell my teacher that I'm cheating. Please don't tell. And she's like a cute little 5th grade girl, so we want to be nice, but the school implementations team has strict instructions from me that if you catch someone cheating, tell me so I can hail ban them and take away like 40 million points. So they need to figure out what's going on. Why is this girl thinking that she's cheating? Well, here's what's going on. Here's how she was cheating. This is almost an exact quote. It's hard to quote from a story, but this is what she said. I look at the hints for how to do one of the problems, and then I remember all of the steps. Then when I go to the next problem, I use the same steps to solve it. So, that was pretty cool to see. If that's cheating, lock me up. This poor girl was sitting here thinking that she's doing something wrong, and we had to sit and think, what's going on? Why does this girl think she's cheating? And what we think we're seeing is the difference between somebody being taught and someone learning. This girl hadn't had a teacher come over to her and say, hey, when you encounter a problem like this, do this, which is the standard mode of, how she should be working through her problems. Instead, she had been a little bit resourceful, a little bit hacky. She was looking at the problems and she decided to click hint a whole bunch and figure out some things and then maybe, write some things down and apply them to the next problem. She was hacking a little bit, and I thought it was awesome. And we all did. And, the more that this type of stuff happens, the better. And I just want to, I want to, who here has read Ender's Game? Okay, great. And how about Diamond Age? Okay, not quite as many. So both of these stories have awesome imaginations of what the future of education could be like. And Ender's Game, Ender's desk that he carries around is basically an iPad that learns with him, and it presents him with puzzles and environments to solve that are extremely relevant to what's going on in his life right now. And the exact same thing happens with the Young Ladies Illustrated Primer and Diamond Age. And both of these books are publicly talked about and acknowledged within the Khan Academy as major inspiration for what we're trying to build. In both of these books, in Ender's Game and in the Young Ladies Illustrated Primer, there's a culture of hacking. In Ender's Game, there's actually holes built into his educational desk that not everybody knows about, so that he can kind of find his way around the system and mess with other kids and learn new things a little bit outside of the system. And in Diamond Age, she's presented with problems that she has to hack around in all these novel ways, all by learning on their own. And while we don't have anything in Khan Academy right now that's some sort of deliberate wormhole that kids have to find to cheat, the more kids feel like they're cheating because they're just figuring things out on their own, fine by us. And I thought that was an awesome story. Let's take a really quick technical dive into what she was looking at when she was cheating. Here's the top of our knowledge map. It starts with basic arithmetic. If you dive in, you can start practicing very basic arithmetic. If you click hint a whole bunch, it'll break down dynamic hints for the entire problem. You can go down further and get into more complicated arithmetic. Again, breaking down, with every single problem having hints that you can click through and break it down. You can go further and you get some graph, some simple geometry problems, and when you click hint, it might modify the graph a little bit. All of these problems are dynamically generated, so there's an infinite number of problems for everybody, and with those infinite number of problems comes, perfectly matched hints for every problem. Here's age word problems, and if you click hints, it breaks it down. We actually do this cool thing with our word problems that spammers use to trick Google, where you have semantically equivalent chunks of sentences that you randomly spin to combine sentences, and we do that to make it really hard for our 5th graders to parse the sentences, which is kind of cool. But it goes way beyond that. You can keep going down the knowledge map, and you get into conic sections, more complicated stuff. Oops, I missed something. Here's the hints for the conic sections. It actually modifies the graph. You can get into calculus. Here's product rule, and here's all the hints for product rule. You can zoom out of the knowledge map and take summative assessments and all that stuff. And so what I'm trying to get across is, think in your mind, how would I be coding this? How would I have this much mathematical content, all generating random problems, all with perfectly matched hints, without having an explosion of code that just becomes this big morass, and every time we need to change something, we're totally screwed? This example is actually pretty cool. Remember when I mentioned the new way of learning fractions? This is an exercise where the student just has 2 buttons, they're hidden, they're off the screen, but they say cut and copy, and you're given a big chunk, and it says, this chunk is 1 4/9 long. Cut it and copy it as many times as you need to in order to create a chunk that is 5/9 units long. And we've been talking to a number of educators about various ways of learning things, and this is an example of a new way of learning fractions that we're experimenting with right now. Things have gotten even more interactive. This is a unit circle exercise. It's kind of hard for you guys to see, I think, but you can drag this thing around the unit circle in order to solve the problem. And again, that one has full interactive hints, and when you click hint, it moves the thing around the circle. Here's that derivative intuition exercise again. Obviously, you can still always watch a video if you're stuck, but the question is, like I said, how do you code all that stuff up? How do you not have a big morass of ugly code? And this is how it works. The exercises team has done an awesome job with this. This has nothing to do with me. But they've built, if this looks familiar, it's probably because it looks like HTML. It is very, very similar to HTML. It is HTML, but it's got a couple extra attributes, a couple extra elements, so you can do things like declare variables at the top of the file and then template them into different spots when you define your problem. Here, let me go to the next thing. That middle chunk of code is defining the problem, and it spits the random variables into there, and then that other chunk is a really quick way to generate a graph. And then this chunk down here, this is just a div with a bunch of p tags in it. And it automatically gets turned into these dynamically generated hints. Every time you click hint, it reveals another p tag. So what we have is this, we believe in HTML. John Ressig's on the team. We want to embrace kind of standard ways of doing things, and this has given us a way to build to scale up code as content without having just this ugly code permeate all the way through our whole system. And this has all been released, by the way, as well. It's all open source. All of our stuff's MIT licensed. You should go play around with this. And more so than play around with this, you should join us. This stuff, we've spent a lot of time, specifically with the exercises, making it easy for the community to come help us and if you have a really intuitive understanding of calculus, or maybe a teacher has a really intuitive understanding of calculus, and they only know enough, HTML and JavaScript to get by, they have a really good shot at contributing some content to Khan Academy that makes a big difference in the world. As soon as we drop in a new exercise, 40,000 people go start doing it immediately. So if you got an independent study or something, or you just want to come hack around, you can come join our hip chat room, hang out. This is a great open source project to be a part of. And also, if you want to learn a little bit more, go check out John Ressig's blog. His most recent, I think currently his most recent blog post is on the Khan exercise rewrite. It gets into that templating system even more, and it's very cool. So, and just as proof, these exercises, derivative intuition and unit circle, those were made by community contributors. Those are guys who just stopped by. Actually, one of them said, he'd barely done any programming before, and dropped in these exercises for us. This is not by a Khan Academy team member or any of our interns. All right, so back to this girl, back to our main story. Everything that I've told you so far is, what we've been talking about is the story of the last year. The company was officially formed in October 2010, almost exactly a year ago now. And these three stories have been important to us, but over time, stories 1 and 2 have started to shrink. And now when we go into a classroom, it's much more likely that we run into story number 3, that kids are just kind of working and they're cruising along. And some of the bigger fires or the bigger problems have been put out now. Things like tools that this teacher didn't have. Here's this teacher who's willing to sit down. Again, another true story. When we've seen a kid raise their hand and say, "Hey, I don't know how to do this," and the teacher comes over and they're working on the Pythagorean theorem, and this is 5th grade. And the teacher says, our teachers are phenomenal. They're totally fearless. The teacher says, I don't really remember that either. I'm going to sit down and learn that with you. And that type of interaction is really inspiring to see. So we figure a lot of what the Khan Academy is about is enabling those teachers. If a teacher is that fearless, then we should be working hard to give them the tools that they need. Here's that one tool that we shipped early last year, which lets teachers quickly spot who needs help and what they need help in. Here's another tool. You can't quite see the blue, I don't think, but the lines that you can't see are blue lines. This is a student's history while working on Geometry 1, is that what that is? And all the little video icons are when they watched the video, the red bars are when they got it wrong, and the height of the bar is how long they took solving the problem. So now a teacher can see, how long are you taking to learn this stuff? Are you getting faster over time? Are you learning over time? Are your mistakes decreasing? And did you take time to watch a video? And then they can click on those individual problems. If, let's say you click on the red problem. I'll come back to that in 1 second. Say you click on the red problem and you want to see, what did you get wrong? Well, all that color stuff at the top there is something that one of our interns shipped in July 2011. As a side note, when we hire interns and new people, we kind of throw them in the deep end and expect them to make major user-facing features as opposed to some sort of internal tool or small bug fixes. But what this is up at the top there is a full history of what the user did while working on this exercise. Here they started, then they waited a couple seconds, then they tried to answer 2/7 and they got that wrong. Then they clicked on the next hint and they saw this hint. Then they clicked on the next hint and they saw that one. And then they tried again with 1/7. And then they clicked again and then they waited 4 seconds and they finally got it right with 3/7. So this teacher can go and see exactly what's going on, dive in, work through with the student, say, why didn't you take a little bit more time when you were working on this, or talk to the student about the mistakes they made with full contextual history of what exactly went on when a student worked on their entire history of problems. And I want to just back up to this one graph I skipped because it's one of my favorite graphs. This is, again, real data. All these grayed out lines are all the students from Juan Los Altos classroom. This blue line is a highlighted student. What you see here is a month, maybe even a month and a half into the school year. This student was, kind of in the middle, certainly not at the top of the class, not even close to it. If you had snapshots, taken a snapshot test, this happens all around the world right now. You take a snapshot test early in the year and you figure out where the student is, they'll be tracked in the average class. Maybe for other students, they'll be tracked in the, the poor or the slower moving students, and they're screwed for the rest of the year or life or however you want to define it. But, whoa, I almost spilled that. This student, maybe they just had to sit on something like subtracting negative numbers for a week. We see that. Maybe you just have to subtract a negative number from another negative number 500 times, we've seen that, until finally it clicks. And then you no longer have this gap in your education and you can move on, and this student is now at the top of a class and at the top of a very talented class as well. So that chart, again, this is a teacher's report, they can see this, and that's a really important one to see. So here we are. Doors 1 and 2 are very, very small these days. We still jump on them as soon as we see those problems, but door 3 is really full. And we're going into the future now. I want to give you a tease of what Khan Academy is heading towards. We've got the 1.8 million problems per day. When we ship a new exercise, it's immediately tackled. It's used all over the world. What happens in the future? And I want to tell you about the type of problems we're solving now that we've gotten past some of those easy fires that we had to put out immediately. Think about the history of academic progress that we are now keeping track of in our data store. Here, if we look at let's say we look at the module Addition 4. We have 3 different users in this case, Monkey, Bob, and Bobette, and we have their full history. Monkey got a problem right, and then 3 wrong, and then 4 right and 1 wrong. We know how long it took them. We have their full academic history. We have that for Addition 4. We have it for Logarithms 1. We have it for inverse trig identities. And what we want to start doing is coming up with more and more models that let us try to answer the really important question, when has a student mastered a concept? Right now we have a very simple system. You have to get 10 in a row and then you've mastered it. That might not always be the case. It might not be, it might not require 10 problems. Maybe Bob here after 4 problems, after these 4 correct problems, is now proficient. Maybe Monkey's proficient after that one. Maybe, well, Bobette's probably not proficient, but maybe in some algorithm it thinks that Bobette is proficient. And the whole point is that we need to be able to test these algorithms and take advantage of all of our historical data. So we've got another intern right now building this thing called the Proficiency Models Showdown. And this is going to let us throw things like naive Bayes at that set of data, and any type of classifier we can come up with, any type of heuristic we can come up with, and see if we can start to correctly predict, given all of our historical data, in the minimum number of work done by a student, how quickly can we identify that they have mastered all these concepts? So maybe one algorithm says, hey, you're proficient here, and another one says you're proficient there. The question is, what happens next? We have all that data. How many times was the algorithm right? How many times was the algorithm right when 30 days passed by before they came back to that problem? Or 60 days. We have all these measures, and there's a whole bunch of data to be used there. So we're facing all these cool big data-ish challenges, and they're all tied to some really meaningful problems. So as we wind down, you guys have this in the back of your heads, the type of stuff that we're now starting to work on. I just want to show you one clip, which is a really powerful summary of some of the changes that Sal has been able to make by starting the Khan Academy.
My name is Mark Halberstadt. Growing up, I was really always a C student. I think I was really pretty much always pretty pitiful in school. I don't think I've ever gotten higher than a B+ in any math class ever, particularly. I pretty much thought that the only thing I was good enough to do in college was major in music. And I went off and I got a music degree in saxophone, and had a great time doing it. I really enjoyed it a lot. But I sort of almost felt that it was more I was getting it because I was terrible at everything else. Kind of worked as a saxophone player for a few years, but sort of knew that I really, wanted to do more, I guess. I knew that I really wanted to, what I wanted to do was do electrical engineering, do more hands-on with math and science types of things. The last thing that I remember seeing in my mathematical career in high school and the last thing that I remember completely not getting was trig identities. So I went to YouTube and I did a search for trig identities, and the Khan Academy was the first thing that popped up. Watched a bunch of videos in the trig playlist to kind of get caught up to speed. I watched all the videos in the calculus playlist. I watched all the videos in the physics playlist. Watched a bunch of videos on dividing decimals and even on subtraction by borrowing. I watched a lot of videos on arithmetic. And anyway, that was in 2007. I did that until the fall of 2010. And in the fall of 2010, I took a leap and I decided to go go back to school and get into a degree program. And I went to Temple University, majored in electrical engineering, getting a second bachelor's. And I guess I'm making this because I just finished my first full year at Temple. I got perfect scores on both of my calc final exams and also on my chemistry final exam. I ended calculus, chemistry, both calculus classes, Calc 1 and 2, and chemistry with an average higher than 100%. There are some Khan Academy videos that I probably listened to the same concept over 20 or 30 times. And there is no tutor in the world I could have paid to have sat next to me and repeated the same thing over 20 or 30 times without at least them getting a little bit judgmental, or at least them thinking like, oh, well, this guy really is never going to get this concept and he should just give up. Where the understanding really happened was watching those videos and also working through the Khan Academy software and everything. The impact for me in my life, I really see it growing exponentially over the next 20 or 30 years. So from the bottom of my heart, thank you.
So, thanks. I'll pass that on to Sal because he deserves all of that. But also, don't tell Sal what I'm about to tell you here, which is that, well, keep in mind the impact of that video and all the things that I've talked about, and then remember how much you care about your code and stuff like that, and realize that as recently as February, all of Khan Academy was in this one file called main.py. You could keep going down, like it got even long. It was way longer than this would show you. It was just main.py. It was even longer. It did the talking to YouTube and the rendering and the blah blah blah. The admin panel, main.py, right? And everybody would say, "Oh my God, how gross! Who wants to work on a project like that? That's disgusting. Obviously, those guys are stupid." But Sal had more important things to do with his time. It's not main.py anymore. We fixed some of that. But he had some really important things to do. So I guess one thing I want to get across is that if you ever find yourself sitting down and perfecting code for the sake of perfecting code, without really understanding, you're trying to solve a problem. You have users. If you want to write great code because other programmers are going to use it and that's going to help users down the future, great, do that. But great code for the sake of great code, I don't think is nearly as powerful as the type of problems that you could choose to dive in and solve if you wanted to dive in and solve them. So if I've talked about things that are really interesting to you, if you think that these type of data problems connected to education are really interesting, I'm going to be around for the rest of the conference. Please come talk to me. We didn't have a booth set up, but I'm the next best thing, so I'll be available. You can go to this URL, khanacademy.org/jobs. I'm Kamens on Twitter. I'm just Ben at khanacademy.org. And I think I talked a little fast, so we have time left over for questions. And thank you guys very much for bringing me here. Any questions? Yeah.
Is there any thought being put into creating hybrid exercises where maybe they watch a video and then work with real world?
Yeah, okay, so when you said hybrid exercises, I thought you were going one way to say that it was combining videos and the exercises. When you say real-world artifacts, you're talking about, project-based learning. Maybe you see a building in the shadow and you're trying to figure out how long the shadow is after watching the, the video.
Or even boxcar races?
Yeah.
Egg drops?
Yep. Yes. So there's a very critical part of Khan Academy, which none of my talk just talked about, which is that the whole point of all these videos and these exercises, which give you base concept understanding, is to enable that type of behavior in the classroom. We know that if we were to try right now to go, implement in a scalable way something that enabled boxcar races, we're not quite ready for that in a scalable way. But we can scalably get a lot of the crap out of the classroom, get a lot of the, like the problems where some crazy percentage of kids who graduate high school can't manipulate basic algebra equations, stuff like that. We can get that out of the classroom and free up, what we see in our pilots is we free up those great teachers to do things like that. So we're very dedicated in enabling that type of stuff. A lot of the videos are about that type of stuff, and when I talked about looking at what we, thinking about where we're headed 5 or 10 years in the future, that stuff is, dead on. We're aiming right for it. But we're embracing the best effect we can have right now, which is to make sure that everybody can move at their own pace when attaining the raw skills necessary to do one of those competitions.
If you went back like 23 years ago and you had learning disability that pretty much just pushed you through school, what is Khan Academy kind of tackle of learning disabilities and kind of
So Sal didn't start off with that in mind. Turns out that's some of the most powerful feedback we've gotten. We get people who are, 15 years old and maybe they dropped out of school, 20 years old. I've seen page-long emails by 74-year-olds who say, I worked in construction my whole life. I didn't get school. Somehow it missed me. There are a million different reasons you can miss school can pass by. And it could be special ability related. And these people all are absolutely thrilled with the ability to dive in and learn whatever they want. And we're seeing great reactions. There are a number of schools specifically associated with autism and stuff like that who are using Khan Academy more and more. We don't have an official partnership with one of them yet, although the anecdotal evidence is that when we hear from parents with autistic children and other situations like that, it's super encouraging. And it makes a lot of sense when you think about it. So yeah, we're really excited about that. There's no official partnership right now.
So, you mentioned students that show each other badges and
Yep.
that brings that competition.
Yep.
And you could potentially bring in college. I'm going to get this badge just to show this guy around.
Yep.
It doesn't necessarily stick after you're done.
It's absolutely right.
So, that's a problem, right? You guys, when you experience this problem, how do you
Yes, we have experienced it. We've put badges out. Every time we put a badge out, we can look at our data, and it's like manipulating thousands of students, and they start running in one direction instead of another one. Right? It's a powerful stick to wield, and so we have to be really aware of it. That's part of the reason we're so tightly connected to the classrooms, and we've built out teams who are just dedicated to talking to teachers and mining what we consider to be gold, which is a teacher's intuition for whether their class is really learning or not. And we put badges out and shut them down the next day. We put badges out and monitored it over time and shut them down later because we saw people tracking and we believed they were chasing badges that we shouldn't have had originally. There's no way the set of badges we have right now is perfect. And all we can really answer to that question is that there's a lot of bad that comes with any game mechanic, and there's a whole lot of good if you steer it in the right way. We know that if we have any game mechanics, we'll have some bad stuff that happens, but we're dedicated right now as a team to undergoing the experiment and figuring out if we can tip the scales heavily in favor of good. We certainly haven't seen disasters because we shut them down too quickly, and we have seen a lot of good things come from those badges. A lot of the stories that we talked about. The competition, we very much believe you don't see a Khan Academy leaderboard right now, for instance. And we probably won't do that, at least not anytime soon, because there are certain levels of competition that we don't really care about. We don't want students, the whole point of Khan Academy is you don't need to reduce students to a number or a grade or a ranking. What a student really is this full history of the things that they've accomplished. If we had a knowledge map that was full of history and art and everything else, you could click on a student's Khan Academy profile and see, which direction their tree grew, and that's a more interesting portrayal of a student than boiling that down to a letter grade or a ranking or a statistic. And we think with the right data and the right user interface that's within grasp, and we're trying to head there, but it's not perfect. Yeah.
Is there any way to add on teachers that you think are inspirational to autistic people?
Add on. So you're asking if there's a way to submit to Khan Academy and say, hey, you guys should be adding these guys to the Khan Academy, or you want to? Oh, yeah. Well, first email me, but you can also, if you go to our About Team page, there's a million ways of contacting us, and we're still small enough such that that will get through. If you email Sal or Shantanu, they read every email. They won't respond to everyone, but they will read every email. So Shantanu is our president. So yeah, that would be awesome. And we have people who are just dedicated to that. We have one hedge fund guy who came to us and was like, look, I was very effective at a hedge fund because I could sift through all these academic papers and separate the shit from the nut, or the crap from the not crap. And he's like, I'm going to do the same thing for you guys with educational studies and try to separate the crap from the not crap and figure out if these people who are throwing out theories like, have you guys heard of spaced repetition? It's like an algorithm that a lot of systems use, specifically a flashcard type learning system to figure out how often you should ping somebody on a specific topic to make sure that they know that topic while minimizing the number of times you need to ping them. There's a lot of theories based on that thing's core belief, which is that there's a curve of forgetting. You forget things more over time according to this curve. And we've been able to map that curve to our data and verify that it does exist for our data, and with certain constant tweaks. So like I said, we don't think that the way we're teaching right now is the way that people should be teaching in 5 years. What Khan Academy is really about is assembling a team of very technically competent people who are laser focused on changing education in a lot of ways. Yeah. That's another great question. That's the primary example of, first of all the videos right now are Sal, and he does not want that to always be the case. We've started branching out. There are some videos where he works with a girl, Vi Hart. I don't know if any of you have seen her videos. Yeah, she's awesome, right? Oh, cool. Yeah, she's really cool. So we've made videos with Vi Hart. They're on our homepage. Sal's made videos with doctors from Stanford. We're trying to find more and more people who will come make videos. Language is, in particular, one area where we have no choice but to do that. Sal doesn't know how to speak all these different languages. We haven't dedicated time to it right now. I know there's a lot of stuff happening with Duolingo and other things like that who are doing really cool language learning. We're forced to scope down, basically, but there are very few educational concepts which are in need of, revolution, which aren't somewhere on our plate in some distant future, if we stick around long enough, I guess.
Are you guys planning on having a sort of partnership with other people who might come up with the same? Because I know there's a website called the New Boss. Something like this where
yeah, he's great. He's great. Yeah, so we do reach out to a lot of people like Vi Hart, and there are some other people. There's some other things I won't announce now, but yes, we are starting to partner with other people who make really good content. We don't, at the moment, have some particular. There are plenty of versions of Khan Academy in which you can imagine where it says submit video, and you submit a video, and then there's a ranking system, and then there's stars, and when you need to go learn about algebra, there's 15 different algebra videos with various rankings and comments, and you can pick the best one, and the best one naturally will bubble to the top. So we haven't gone that route because we believe that it's really important to keep the quality as consistent as it is right now when you go watch one of Sal's videos. I have a feeling there are going to be some companies that start in that direction, and then it'll be us starting in our direction, and we'll probably meet somewhere in the middle. I think in the distant future, we have an API, but it's read-only right now. But we're very dedicated to making sure that the community can contribute content. So while partnerships might not be something that I'm ready to totally answer right now, we absolutely are thinking hard about how to start incorporating community submissions of both videos and exercise content without sacrificing, consistent quality. Yeah.
Do you hear resistance from some teachers about the idea of using Khan Academy option, and what are those?
Yeah, great question. There are a certain group of teachers who are very active on Twitter and are very opposed to Khan Academy, and they represent a couple different groups. One group is a group of teachers who doesn't understand Khan Academy at all and thinks that we want to they argue that project-based learning is the right thing to do, so Khan Academy sucks, while we're trying to say we're trying to help you do project-based learning. So there's like a fundamental mismatch of that going on there. They think we're totally like anti-project-based learning and anti-teachers, which is not what we are. If you talk to anybody on the dev team, we spend a lot of our time trying to help teachers. So there's one group of teachers who are just coming from a fundamental misunderstanding. There's another group who really honestly believe, and a lot of this is in the physics world, really believe that the right way to learn something is just to be presented with a situation and kind of go through this Socratic learning process. It's a constructivist learning argument. Go through this like Socratic learning process of asking questions and discovering a lot of things from new. We don't totally agree with that. We think that A, doesn't scale, and a lot of the people who are upset with us are not positing any sort of solution that will scale in education. And B, it ignores the facts that nobody is willing to state. I'm not going to say the exact statistics because I'll get them wrong, but the statistics about the numbers of people who graduate high school, specifically people who don't speak English as their first language, who cannot manipulate an algebraic equation. And we think that as long as you continue to ignore that, you're putting yourself out of a lot of the core, most important pieces of the argument. So yeah, there are people who disagree a lot with Khan Academy, but there's a certain group who I think if they were close to us, it wouldn't be anything like that. And when we engage them, the conversation drastically changes into this nice engagement. But when they're on their own, they get really angry with us. Most of them don't seem to understand that we are on the good teacher's side. It's been said before, if you could be replaced by what Khan Academy does as a teacher, you probably shouldn't be a teacher, because there's a lot you could be doing. The best teachers are doing a lot more than that. They're sitting down with kids and coaching them and helping them, and that's what we want to enable. Oh, good question. That's Prezi. Sorry, so he asked what was the presentation software that was being used there? And that was Prezi, which lets you zoom in and out of an infinite canvas. There are actual bug reports on Prezi from people becoming seasick watching it. If you guys felt like vomiting, I apologize. Hopefully not. I didn't go crazy. I actually tested not this presentation, but a different one because I was worried about this on Khan Academy developers, and I had a face of Einstein that was spinning, and they were zooming into Einstein, and nobody vomited, so that was good. Yeah. Yep. That's a great question. So the question was, what happens when you bring Khan Academy into a classroom and then a student is either computer illiterate and just can't manipulate the software, or they don't have access to a computer at home? So let's tackle the second part first, the computer at home. None of the classrooms that we're implementing with right now require Khan Academy work outside of the classroom. So yes, there is a big advantage if you can go work at home, but I would argue that there's a big advantage right now if you have a computer at home and you don't anyway. And we have to pick and choose which problems we can solve right now. So it does suck if a kid doesn't have a computer at home, but we are not, in any of our official implementations, suggesting that you should require work at home. So that answers the latter part. Computer illiteracy, we just haven't run into. In the Oakland classrooms and 5th grade, 7th grade classrooms, we put out that new Google Maps API thing that was brand new about a year ago, and I was super concerned that kids weren't going to know you have to zoom in and out of the map and stuff like that. And so we went and visited the classroom, and I thought everything was broken because all these kids, it was all inverse. It was like the background was black and the text was white, and I thought I had a terrible CSS bug. And I was like, what's going on? And they're like, oh, no. It's just hard to read the knowledge map, so I invert the contrast on my machine and blah, 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 and keep going. I had no idea how to do that, but all the kids knew how to do that. All I can say is so far it hasn't been an issue at all. Mostly it's the teachers that have the issue with the user interface and not the students. Yeah.
So going back to the teachers thing, one big problem is bad teachers. I see you guys talk about that on project.
No, we are not right now aiming to use this to track and analyze a teacher, because we believe there are way too many variables for that right now. We do think that if you can track a student over time through many, many years and do that for lots of students through lots of teachers, gradually over time that might become, that's more useful data certainly than any data you have right now on test score performance or something like that. But the last thing we want Khan Academy to become is a world in which teachers are helping kids get through the software so that they get better marks. Those are just screwed up incentives. So right now, the answer is no, and the more important answer is that when we think about what to work on, we think about students. We know that if students are happy in learning, that the teachers will be on board. We've put out fires for teachers where they need to be put out, and we really care about the teachers, but if it's going to screw with a student, then we just don't really think about it. Yeah.
So judging by Joel's Goldsmith's blog, Creek Software is a good place to work.
Yep.
What made you take the leap?
Great question.
Joining a company like this?
Great question. Yeah, Fog Creek's freaking awesome. If any of you guys, yeah, put in my full plug for Khan Academy, Fog Creek, and Stack Overflow. Yeah, I was at Fog Creek for almost 6 years. Absolutely loved it. I started interning and gradually was leading a whole bunch of teams. And I started working on Khan Academy in about March of 2010. I was working open source. I was still, launching Kiln and working at Fog Creek. And I was working on the open source project, contributing, getting more and more involved, and it was just so rewarding to me that when the company formed and the opportunity presented itself to go work on Khan Academy, I came up with this calculation where I said, if the Khan Academy fails, I'm going to be really pissed at myself, because you could look at the main.py and I was like, I know I can help. I know I have the tools to help, right? And then if it succeeds, I'd be really pissed at myself, because how cool is Khan Academy? I need to be a part of it. And I figured that, given those two situations, I had to take a shot. But yeah, no, I still have a great situation with Joel and Fog Creek, and much love to Fog Creek. If anybody here is saying, I saw a Kiwi shirt somewhere. Yeah, great shirt. So yeah, check out Fog Creek as well as Khan Academy. Yeah, great question. The question was, what do we do with kids who have moved forward too fast, and now they were in 5th grade and they got through trig, and they don't have anything else to learn in math. Also, sorry for not repeating the last question, which was why did I make the jump from Fog Creek to Khan Academy? If you didn't hear that question, but in answer to your question about content, first, it's an interesting question to ask, and it is either really cool to hear it or really depressing to hear it, depending on who it's coming from. If that question comes from a teacher or a school administrator, you get really depressed, because you realize that there are great people who are in a system where they are concerned that a kid's going to be shoved into some spot in the system where they don't have anything to learn, and oh no, what are we going to do? They already know everything. So that's a real situation we've encountered, and it's just a sign of it's a sign of the system being broken when kids have to only be segregated by their age. Some of our school pilot programs, actually I'm not going to say some, one of our school pilot programs right now is engaging in what Sal would consider the full vision of Khan Academy, where you have students of all ages working together through a whole bunch of different topics. And the older students tutor the younger students, and when appropriate, the younger students tutor the older students. And so that type of stuff is going on. And I think, if we could all dream and have the perfect situation there would be, that kid's not in a situation where they're stuck in this age-specific progression, so you don't really ever have this problem. But given the case that you have this problem, right now we're pretty dedicated into, we're growing our exercise team fast, and we're working hard, and we consider it a personal challenge to make sure that there's nobody who has mastered everything in the Khan Academy right now. So we're in a race, and we're gonna branch out in math, and we're gonna do physics, and we're gonna do chemistry, and the exercises will get more interactive, and maybe we'll have a static collection of questions for art history. So if the student has conquered all of math, and maybe he's really into math, in which case there's plenty of things he could do. But if he's not into math anymore, maybe you spend your time in physics, you spend your time elsewhere, and hopefully we'll have that content available. So the question was, are we going to go further and deeper in terms of, you're talking about student assessment in particular, right? In terms of student assessment exposed to the teachers through all this data we have. Right now, I would say that the answer to that is when a teacher is running into misery in their classroom because they have to click through 1 million reports, or they just can't get access to the data that they would take action on in order to teach a student better, we will absolutely engage that, and that's what we're doing right now. We're not trying to come up with some other way of ranking or assessing students to compare across classroom or anything like that right now. We are definitely thinking about more and more ways to expose the student's work to a teacher. We have this little scratch pad, so it kind of sucks on a computer. It's really cool on an iPad. If you're working through a problem, you can take notes on a canvas, on the web page. it'd be really cool, especially if you're doing that on the iPad, if the teacher could see the work that the student is doing as they take the note. And it'd be even really cool if we had handwriting recognition and you didn't have to click in a form field and enter the answer. But that type of stuff where we're just exposing more and more of what we consider to be the truth of what happened when a student tried to learn something, we're absolutely exposing more and more of. I don't know if that answers your question, but we're not working hard to boil down students into some other type of metric that would be useful for teachers to assess. Well, something that we really steer away from is if a teacher ever comments on our blog or something and says, hey, I'm trying to grade today's work on Khan Academy and they only got 8,000 energy points, so is that a B or a C? That's not what we want. That's really bad, because that's going to make gaming of the system about 50 times worse. We've had offers of partnerships like, if they get X points, they get X pizzas or whatever. We don't want to jump the shark there and all of a sudden have our game metrics become less intrinsic and more extrinsically motivated. Yes, absolutely. We're definitely not building Facebook where the default controls are exposed. First of all the stuff that you saw here, a student has to add a coach as their coach. We use the word coach instead of teacher. A teacher can't add a student, and a student has to verify everything. And then once a student has added a coach as their coach, the coach can see the student's work, and the student can always remove it later on. So you always have full control over who you expose your data to. At the moment, we actually, because we're concerned about that, we have no concept right now of a public profile or some sort of like flare that you'd put on your blog or your Twitter or whatever. We will, and we're going to have to be really, really aware of making sure that students know what they're exposing. If they don't want people to know that they struggled with this, then we need to not expose that. So all I can say right now, I guess, is that we've only exposed a little and we've been really careful, and as we expose more, we'll continue to be careful.
Have you had a student actually have the shoot spot and get mad at their teacher and remove them?
That's a good question. I don't know. No, I don't think I've seen that much spine happen in the classroom. Part of the fun here is that the teachers really go nuts because the students don't know it. They don't have a full understanding of everything that the teacher can see. So one of our teachers, Rich, will walk around and be like, I can see everything you do. When you go home, I know what you're doing, and stuff like that. But no, we haven't, in the classroom, no. But people use the coaching functionality outside the classroom. I'm my mom's coach, so my mom was always really behind in math. She finds it fun to try to go relearn it. So I can watch her progress, and soon I'll be able to set goals for her and stuff like that. If I ever pissed her off, she could remove me. Yeah.
All right, and in TED Talk, I think I remember hearing Sal say that you basically go at home, listen to a lecture, and then come in class and then do the problem. Well, in response to the thing that was said earlier, you said that you weren't really requiring a computer at home. So how would that be a possibility? And how is Khan Academy taking the steps to do that?
Yep, that's a great question. So the question was, if we're in the TED Talk, and a lot of the media about Khan Academy talks about flipping the classroom, which is this concept that students go home, they watch the lecture, they watch the video, and then they come in and they work on problems together in the class when they have access to the teacher. And so if students don't have access to the computer at home, how do you flip the classroom? Also, sorry, I'm really bad at repeating the question. If you guys just yell at me or throw something at me if I don't do that again. But the answer there is that in our official pilots, the media has picked up a lot on flipping the classroom, and a lot of people who have implemented on their own have flipped the classroom. In schools where we go into, we haven't mandated flipping. It happens sometimes when the teacher has judged that everybody has equal access at home to the computer, but it's not some sort of prescription Khan Academy step that you take, and if a kid doesn't have a computer at home, they're screwed. So, the real answer to that is that flipping the classroom is really important to us, but what's even more important to us is a lot of the stuff that we saw demoed here. Yeah.
I have two questions. One is, do you consider once the subject is mastered, that it's always mastered, that you come back and look at it? And two, I have young children who I've tried to get on, and I think, I may be wrong here, but the only way that you can get a login is through having a Gmail account.
Yep.
Yep.
Yep. Two great questions. Let's start with the second one. The second one was, you can only log on with Google and Facebook. They have strict laws that say you must be over 13. How do you get an account? Sometimes what we want to say to this question, which is not the official answer, is put your kid down in front of the login screen and then leave for 5 minutes and see if they're logged in, but that's not the official answer. So we usually only hear this from the parents who are concerned about the Google and Facebook login screen. Right now, this is super complicated. I'm not going to bore you with it, but there's strict laws about what legal agreements students can agree to if they're under, or kids can agree to if they're under 13. So you can't really get a student's account unless you follow all these procedures in terms of not tracking their data and not having any identifiable information. And we haven't fully embraced that yet in order to create a login system that will work for under 13-year-olds, because we've wanted to just offhand the authentication system to Google and Facebook. As a result, we get questions like this, and it's really important. In the schools, it's really easy to work around because there is this. Have you looked at Google Apps for Education? So Google has this thing called Google Apps for Education. I think you have to pay $50. And if you're a teacher, and it might even be that if you're a parent, especially if you're a homeschooled parent, you set up an account, and then you can create a child's account which you have control and visibility over in Google land, and that satisfies COPPA laws and it offloads legal responsibility to the parent or the teacher, and then they can set up accounts for everybody that's under 13, and then they get logged in. If you go to About and then Getting Started, there's like a little thing in there that talks about using Google Apps for Education and what do I do if I'm a parent with an under 13-year-old kid. We do have a lot of parents right now who just create Google accounts for their children, and as long as they know the password, then I think it's legally okay. But please leave me out of the legal debate for now, because we haven't properly tackled it. And so at the moment, it's either got to be Google Apps for Education or you're over 13 with Facebook or Google. Also, we recently made a change so that you don't have to be logged in to use a lot of the system. You don't get quite as permanent storage, so I don't recommend it, but anybody can go in and start using it. Oh wait, there was another question. What was the first question?
Do you assume once mastered, do you assume always mastered?
Yeah, good question. Once somebody has mastered a subject, have they always mastered it? Absolutely not. We have a review mechanism. Right now it's kind of similar to spaced repetition. Once you master something, I think it's like a couple days later, it'll ask you to do it again. If you get it wrong, that influences how long we're going to wait before we ask you again. If you keep getting it right, we start asking you less and less. And we have, a knowledge of the relationships between those concepts. So if you've mastered the product rule, we probably don't need to have you review addition 2. Maybe actually multiplication 4, which is interesting. But we have all those relationships built in, and we do ask people to review, and that's a very important part of learning is reviewing over time. Okay, cool. One more question. Let's go with the far back. I think if you asked me this next year, the question was, have we tried to go into a classroom and have them use Khan Academy and they suck, or they think we suck, and then they don't suck, they think we suck, and then do we manage to change their mind? And I think if you asked me this next year, I would say yes, but right now we're so firmly in the camp of only wanting to work with people who want to work with us that that's not an issue. The last thing we want is to have some Khan Academy implementation out there where the teacher hates it and they're just getting through the day with Khan Academy, because the kids aren't going to learn. The teacher's critical. The Khan Academy is not going to save everything. So if the teacher hates it, we don't want to be there. We're not doing. We do have one district-wide rollout in Los Altos, but we didn't have any teachers that were upset about it because they participated in the pilot the year before. We don't want to have some situation where administrators are throwing Khan Academy down teachers' throats. So right now we don't do that. Yeah, thank you guys.
Thank you, Ben. All right, guys, so MacMania opening ceremony is going to be happening at 9:30 here, and that is followed shortly by Josh Block's talk on puzzlers, so stick around after that if you're not participating in MacMania. Excuse me?